Hi, in this short video, let us learn how to apply Leibniz rule to solve these kind of problems. Okay, so first of all, let us see what is Leibniz rule. So whenever you have an integral like this, which is the limits are a of x and b of x, f of t comma x and you are integrating with respect to dt. Okay, and this Leibniz rule says that when you differentiate this entire expression with respect to dx, why? Because after integration of this expression, you will get a function of x finally. Okay, so some g of x, you will get it here. So I can talk about its derivative. So its derivative is defined like this. First, you differentiate the inside expression with respect to x, and then you integrate as it is with the same limits. Then you substitute the upper limit in place of t. So that's what we did here. And then you take the derivative of the upper limit. Okay. And next, minus. Now you substitute lower limit in place of t, which is here. And then you differentiate a with respect to x. So this is what Leibniz rule exactly. Okay. If you want details how this formula is defined, you can actually see this f as a function of three variables. It's like, why? Because here x is involved. Here you can see that x is involved and a of x and b of x. So we are going to see this as a function of three variables, x and a of x and b of x. You can do one thing, you can just assume it like this is g is a function of these three guys, and these three guys are again a functions of x. Then how do you define derivative of f of x here? Using chain rule. First you differentiate g with respect to first guy and derivative of the first guy with respect to x. Similarly with respect to second guy and derivative of second guy with respect to x. Similarly the third one. Okay, so here in the first differentiation, okay, here this guy is nothing but x only. So dou x by dou x, it becomes 1. And that's what exactly the first part of the expression. Differentiating it. Okay. And the second expression is derivative with respect to b. That's why the upper limit is substituted and we differentiated b with respect to x. And next one is about the lower limit a. So you can write it like f of a comma x, and you can differentiate with respect to x. Differentiate a with respect to x. Okay, so this is what Leibniz rule says. I hope it is very easy to remember. You can see that just you differentiate f with respect to x first with the same limits. Next you substitute upper limit, derivative of upper limit minus f of the lower limit comma x into derivative of lower limit. Okay, so let's do one thing. Let's solve a problem like this. So here if you observe that f of x is looking like this. It is a of x times, a of x, and the upper limit is b of x. And here if you observe that you have function of t only. Okay, but in the formula you have a function of t comma x, but here we only have a function of t. Okay, so when you have function of t only, then what is the derivative of f with respect to x? This would be 0. Why? Because f is a function of t only. So in the formula, you will not be having the first part. This becomes 0. Okay, so you'll only have these two things. So in that case, if you observe that, the formula would be this. I hope you can see it here. So when you have integral a of x to b of x f of t into dt, its derivative with respect to x will be just f of upper limit into derivative of upper limit minus f of lower limit into derivative of lower limit. Okay, so this is the formula we are going to use to evaluate this problem. Okay, so now let's try to identify. I think I wrote f of x here. Then I must write, this one I should write it like g of t. Okay, then here I must write some g of t, not f. This must be g. Okay, this f and this one may not be same, they can be different. Okay, all right. So now here just let us try to identify what is g of t here. So in this case g of t would be sine t square. Okay, sine of t square, and a of x, which is the lower limit 1 plus x, and b of x, which is the upper limit x square plus 3x plus 1, sorry, minus 1. So now let's recall the formula that we are going to use here. Yeah, which is exactly here. I hope you can see it. Okay, so but here I'm taking g in place of f. That's the thing. So you can take this as g without confusion. Okay, all right. So let's do one thing. Let's just substitute upper limit. So what is it? What is the answer for it? So therefore you can write f dash of x. So f dash of x, which equal to g of b of x, okay, into derivative of b with respect to x, minus g of a of x into derivative of a with respect to x. And you know what is g of x, and you know that which is nothing but sine of t square. Therefore this is sine of, you know what is b, x square plus 3x minus 1 whole square, and derivative of b is going to be 2x plus 3 minus g of a. So the a is 1 plus x, and derivative of, okay, then it's square, and the derivative of 1 plus x is 1. Okay, so this is what f dash of x is. But what is the question? The question is find f dash of 0. Okay, let us plug in x equal to 0 directly. So if we plug in x equal to 0, therefore f dash of 0 equals to, this is exactly sine of, you know, 0 minus 1 whole square, and this is 2 times 0 plus 3 minus this is sine of, you can see that that is 1. Okay, and now this would be what, sine of 1, that is 3 times sine 1 minus sine 1, and that becomes 2 times sine 1. So this is the answer for f dash of 0. Okay, suppose if you are asked for f dash at some other point, yes, we can evaluate it. Okay, so now let's look at one more problem. So this is the problem now. So here in this case, if you observe that f of x can be seen like this, f of x can be seen like integral some a to b of x, okay, and this is g of some t comma x into dt. This is how you can see. Okay, earlier we have only function of t here, but the presence of x, you can see it here. Okay, so the question is to find f dash of 2. So first let us find the derivative using Leibniz rule. So what is f dash of x using Leibniz rule? Which is, so first you'll write the limits as it is. So first you need to differentiate the inside expression with respect to x. Okay, so that is derivative of e power tx over x, sorry, over t with respect to x into dt. Okay, and this plus, now g of upper limit. What is the upper limit here? In place of t, I need to plug in x square times you have x over x square times the derivative of x square is nothing but 2x. Okay, just for clarity, let me write it like this: derivative of x square minus the other expression would be 0. Why? Because the lower limit is 1, right? What is the derivative of 1 with respect to x? That will be 0. Okay, so no need of no need to write about that 1. If you want, you can simply write minus 0 like that. Okay, so now let's evaluate it. Integral 1 to x square. So the derivative of this with respect to x, which is t into e power tx over t. Okay, so into dt plus, now this would be e power x cube by x square times 2x. Now this will be what? I hope you can cancel t and t. So you have a simple integration, that is integral 1 to x square. They are asking about e power tx into dt plus e power x cube, 2 times of e power x cube over x. So this is what f dash of x. Okay, of course we can integrate it. But anyway, they are asking for f dash of 2. So let me just find that. F dash of 2 equal to, what is it? Integral 1 to 4. This is 1 to 4 e power 2t into dt plus 2 e power, this is 8 over 2. You can simply integrate. So integration is e power 2t over 2. Limits are from 1 to 4 plus e power 8. So this is what exactly? E power 8 minus e power 2 over 2. Substituting upper limit and lower limit plus e power 8. Maybe after taking LCM, I hope you can see that this is e power 8 minus e power 2. So this is 3 e power 8 over 2. That's it. So this is the final answer. Okay. So I hope you understand this problem. So here you can see this one is a function of t comma x and this is a function of x, but this is a constant. Okay. Sometimes you may have a function of x here and you may have a constant here. Okay. So depending upon the problem, you need to proceed. But I hope you can understand this formula, right? So if you keep this formula in mind, then any problem can be done of this type. Okay. So there is one more type we can see. That one more type is nothing but when this b and a are constants. So when this b and a are constants, you can see the formula. Let me show you. So this is the formula. Because you just differentiate with respect to x, okay, and this derivative will go inside and it will become like this. And anyway, the limits are constant, no? The derivative of upper limit is constant, the derivative of lower limit is constant, so the rest of the terms would become 0. Okay, so this is the Leibniz rule. Okay, and you may have problems like this. So given something like this, you will be asked to find f dash of 0. But remember one thing, whatever integral I have given here, it is not easy to integrate directly. You can't integrate it directly because you do not have antiderivative for sine of t square. But however, if you want to find f dash of x values using Leibniz rule, we can comfortably find the values. Okay, so I hope you understand. Thank you.